In this video, we're going to take a look at scatter plots and trend lines. Basically, what a scatter plot is that when I have a chart with a bunch of data, I take it and I graph it. So it's basically a graph of data. Okay. So the graph will look like three different things. Okay, three different possibilities. It's usually real life data, so it could look something like this. Okay, it's a bunch of points. There might not be a bunch of sort of relationship between them, but in this case, I would say that it's a positive, what's called a positive correlation. That means that if I look at the data, once again, I always read a graph from left to right, as what we've seen with slope. But in this case, the points in general go up, even though it's not like a straight line. I would say this has a positive correlation because it seems to be increasing as you read the graph left to right. A second situation that you could have is that the points will look maybe something like this, okay? Where in general, most of the points seem to be grouped in this area. This is what's known as the negative correlation. Okay, because all the values seem to be decreasing or going down if you read it from left to right. So we say it's a negative correlation. And the third possibility is when there seems to be no pattern whatsoever. So something like this. Okay, it just seems like a mess of dots. This is what we would say is there's no correlation. There's no pattern that we could follow. Okay. When we talk about trend lines can also be called lines of best fit. Okay. Or a regression line. Okay. We talk in particular with linear regression. Basically what it is that it's a line that models, that kind of goes through the data and seems to model the general sort of average pattern. So we might look like this. Okay, so these are what are called the scatter plots, is the actual graph with all the points plotted from data that you might find. The trend line is the one line, the linear regression, the line of best fit. What seems to model that particular situation? What line can you use to sort of predict what a value would be? Okay, so let's go ahead and look at this. Okay, in this particular sort of example, we showed the altitude of an airplane and the temperature outside the plane. I'm going to go ahead and graph that data, and I get a graph that looks something like this. Okay, if I then wanted to find what the line of best fit or the trend line would be, I would go ahead and look to draw a line. Okay, and to model it, let's maybe have it be something maybe looking like that. So maybe it might look something like that. In general, I want similar numbers of values below as above, and sort of it to be angled through the medium, through the middle. Okay, so I would say this is my line of best fit. I can use it to do something called interpolation. Okay, so this is predicting a value. Within a set of data. So for example, maybe I would like to predict what is the temperature at an altitude of 2,000 feet. So what would be this temperature? And I might say it would be 45 degrees. This is interpolation because it's in the midst of sort of the data. Okay. On the other hand, extrapolation is a prediction outside the value. So for example, I might say, what is the value, say at 6,000 or 7,000 feet? It's something that if the data falls between here, 6,000 goes beyond the scope of it, and I might say then the temperature would be 0 degrees. If I went on, maybe it would be negative 10 degrees, okay, something like that. So that's called extrapolation. Tomorrow during class, we're going to take a look at sort of how to find this equation using graphing technology. If I am not given graphing technology, what I would need to do to find the equation is I would have to take these values. Okay, I would have to pick 2 points. So let's say I picked, say this one, I put so that it was about appropriately. Maybe it was 4,500 feet. And maybe it was a temperature of, say, I would approximate 12 degrees. And then maybe I picked this point here and said it was 1,500 feet or meters. And let's say it had a temperature of 51 degrees, maybe, okay, approximately. I would then use these 2 points and what I know about finding the equation of a line to find the equation. So I would use these 2 points to find slope, pick one of them, plug them into point slope form, get the equation. The good thing about graphing technology is once you input all the data, it will plot the points for you. You'll be able to do what's called finding a linear regression line. It'll draw the line and it will give you what's called the correlation coefficient. Okay. And you want the correlation coefficient, abbreviated as R, to be as close to 1 as possible. Okay? We can't find really the correlation coefficient by hand very well. It's a little bit more complicated. But we'll look at that tomorrow when we look at the graphing technology using a website to graph a scatter plot. And I'll teach you that in class tomorrow, but it'll automatically, anytime you use a graphing calculator, it'll automatically give you the R value or the correlation coefficient as you are graphing, which is quite handy. And the correlation coefficient, close to 1 as possible, what it does is it shows you how accurate the line is. So basically, how many of the values is it hitting? And how far off are all the values, okay? And that's your goal, is to get as close to 1 as possible.